Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 180, I chat with video guru Joe Kane about what's really important in ultra high definition. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CacheFly.com.
This is Home Theater Geeks with Scott Wilkinson, recorded October 28th, 2013. Episode 180, Ultimate Ultra High Definition. This episode of Home Theater Geeks is brought to you by Ting.com. Ting is a mobile phone service that makes sense. Save money with Ting. Pay for what you use. It doesn't require a contract, and it offers unlimited devices on one account. To save $25 on your first Ting device, visit htg.ting.com. That's htg.ting.com. Hey there, Scott Wilkinson here, the Home Theater Geek and Director of Content at avsforum.com. This week's guest geek is Joe Kane, video guru and founder and president of Joe Kane Productions, who is returning to the show today to talk about Ultra HD, or what we like to call 2160p. Hey, Joe, welcome back to the show.
Thank you. It's a pleasure to be here.
Always great to have you with us. We got a lot to cover today, so we'll get right to it. But before we do, I just want to quickly say that those of you who are watching live at live.twit.tv or logged into the chat room at irc.twit.tv can post questions for Joe as we go, and I'll pass along as many as I can. If you include my screen name in the chat room, Scott Wilkinson, all one word, then it'll appear on in a different color on my screen, and I'll see it easier. So if you want to get in, that's the best way to do it. Okay, Joe, so we want to talk about Ultra HD, UHD, which you rightly prefer to call 2160p to make it synonymous, or rather analogous to 1080p, which is our current HD standard. And most of the consumer electronics industry, TV manufacturers in particular, are really focused on resolution and how much better 4 times the number of pixels is. But in reality, UHD is about a whole heck of a lot more than resolution, isn't it?
Well, in reality, it has to be a lot more about resolution, or it's not going to sell to consumers. What I see is, number one, if I'm sitting anything beyond 1.8 picture heights away from the set, I can't see what the resolution has to offer. And incidentally, I have an 85-inch set at home. There's a picture of it there someplace in the files that I presented to you.
That's true. A photo of the Samsung 85-inch.
Yes, that's it.
There it is. In Joe's home. There it is, right there.
And so I actually have a lot of experience with this format. And I find that you pretty much have to sit on top of that set in order to get the effect of the resolution.
Now, I can see your couch right there in the picture as well.
Yes.
And it's what, one and a half screen heights away? Well,
it's at the maximum distance. It's at 1.8. And because I'm trying to illustrate the point that if you get any further away, you lose the resolution that's in the set.
Yeah, you can't see the benefit of the extra resolution as compared with 1080p.
That's correct. And that's on an 85-inch set. And we're going to discuss screen size a little bit further on.
Right.
But I don't believe the format can be just about resolution and survive. I believe it has to be a great deal more than just resolution before the consumer is really going to be interested in buying it. There's obviously going to be the early adopters that will buy a set like mine and get to see it. But if it isn't something more than resolution, it's not going to attract enough consumers to carry on as a format.
Right, right. So what are some of the other aspects that you see as being needed to be included or addressed in the UHD format to make it attractive enough to consumers so that they will buy it and allow the format to actually develop into a mature format?
Well, we would start by saying that what I see as necessary is something that will make the format so much more attractive than our current system as to be, oh my gosh, I have to have it. And there are a lot of things, as an example, a different color gamut, a better color gamut, so that more colors could be conveyed. We might have high dynamic range so that we have more contrast in the picture. We're able to get more dynamic range into the picture than we can get in our current system. It might be a different grayscale so that the color fidelity of the signal is better. It might be a higher frame rate, so temporal motion in the picture is going to be a lot better. Sports will be a lot more fun when you don't see blur in the picture because we've got a higher frame rate. So those are just but a few of the considerations that should be going into the real ultimate high definition system, the ultimate ultra high definition system.
What you've called UUHD.
That's correct. It's the ultimate ultra high definition television system. And I don't believe resolution is going to be anywhere near enough to sell the format. Mm-hmm. In fact, I actually want to see changes occurring in the system that get applied to our existing system so that our 1080p and our 720p gets better. It'll get better in frame rate. It'll get better in dynamic range. It'll get better in color. It'll get better in temporal resolution, in other words, motion resolution. And so I want to see all of those things incorporated in a brand new television system that includes our existing high definition system so that it can also become ultra high definition.
Without having the extra pixels.
Without having the extra pixels, as I pointed out, the extra pixels are only valuable if you're close to the screen.
Right.
But there are so many other things that could make an ultra high definition system truly ultra high definition. And I want to see all of those things added to what is defined as UHD TV.
Mm-hmm. Eric Duckman in the chat room asks, when do you think the 2160 TV standard will be approved?
Well, there is a 2160p standard that has already been approved. It was approved last year in 2012. The thing is, in my opinion, and I'll emphasize, in my opinion, it doesn't work. And as much as it's been codified and it's out there and people are talking about it, I look at it and say, for multiple reasons, it's not going to work. And so I'm proposing that it is nothing more than something to open the door into the real ultimate ultra high definition television system. That's going to be a difficult thing for me to keep saying, ultimate ultra high definition television system.
Indeed.
But I want the system to be a lot more than it is. And therefore, I'm working closely with a number of organizations who would be in a position to add to the definition that came out in 2012 and make it a much bigger system and much more inclusive than it is now.
Now, what you're talking about, the system that already was approved and ratified, if you will, last year, the what is formally known as the ITU-R recommendation BT 2020?
That is correct. That's precisely what we're talking about. Now,
okay.
Incidentally, just as an aside, the 2160p format was actually codified in a large screen format specification. I believe it was 2008. The number is 1769, the ITU number. But 2160p has been codified for a long time now. The only thing that changed in the 2020 specification, or the major change in the 2020 specification, is that it added a color space that is much larger than the color space we're using now.
Right. The color space that we're using now for high definition is called Rec 709, and it encompasses a certain range of colors, and the color space in 2020 is much, much larger. So
yeah, and I included a CIE diagram. There's a CIE diagram in a group of photos that has the 709 in it, and it also, well, that one has the Rec 2020. That's the
there it
one.
is.
Now it shows.
So what we're looking at here, just to make those of you who aren't watching, we're looking at the CIE color diagram. And within it are several triangles that define the different color gamuts or range of colors that are defined for different applications.
That's correct. And in the center of the diagram, the smallest triangle is the 709 triangle that we currently use for our high definition system. And then the next largest diagram is labeled DCI, and that's the triangle that's used in the digital cinema. And then, of course, we see what kind of colors print film can encompass. And then we see an F35 and an F65. Those are Sony ultra high definition cameras. And the one that's labeled F65 is approximately where the 2020 spaces. If we go back to the CIE diagram that has just the 2020 triangle on it, and then go back to the CIE diagram that has a LUTs, you can see that 2020 even goes out beyond what the F65 is capable of capturing. So if you go back and forth between the two of them slowly once or twice, you'll be able to see that the green is even further out in the 2020 space than what the F65 is capable of capturing.
Right.
So you can at least get an idea that the 2020 specification is asking for a lot in color space.
Yes, indeed. Got a couple questions in the chat room. Sorry for zoning out there for a second, but I was looking at the chat room. Jim Jam asks, are any broadcasters thinking about UHD? I think they are.
Well, the best answer I can give you is that European broadcasters are already capturing and trying to deliver in that format, as well as Japanese broadcasters. The reason for that is sort of different in that Europe was so far behind us in high definition. They were years behind us in high definition. They don't want to be caught being behind us in the UHD format. So they're already out there trying to do it now today. There are discussions that the 2014 Winter Olympics that some of it is going to be at least recorded, if not transmitted, in the ultra high definition format. So we're looking for something that's just a few months away, and we're looking for Europe to be broadcasting it. We don't know who will get it and where it'll go, but there are at least discussions in Europe of it happening on an occasional basis in the next few months.
What about, pardon me, what about Japan?
Well, Japan, interestingly enough, is already making motions to go into the 4320 format, which is 4 times the resolution of 2160p.
Right.
So they're already moving into the 4320 format, and
or what is mistakenly called 8K.
That's correct. that mistakenly called, you're correct about that. It's mistakenly called 8K. But they're already moving in that direction.
Yeah.
So
Beatmaster asks, aren't we in danger of using technology for technology's sake, like we did and still do with 3D? Without the content makers seeing a use for it, will we even get into bigger color spaces?
well, I totally agree that we could be misusing a system and or never get a lot of content for it. Part of my concern about 2160p is that it is going to be even shorter in its lifespan than 3D has been if we don't make it something other than resolution.
Right.
And if we don't include 1080p and 720p in the system, in other words, the content providers might be more than willing to step up if it's the same rate. As an example, if we included the P3 color space, the digital cinema color space, there's already lots of transfers in that color space. If we had the bit depth, oh yeah, I forgot to mention bit depth. We need lots of that too.
Right.
But,
we're gonna talk more about that in a minute.
Right. What I'm looking at in my own world is if we include a lot of this, there is the potential for making 2160p or making ultra high definition so compelling that everybody will have to have it. So I agree with the statement that it could fall flat on its face if it isn't something much more than just resolution.
Right.
So that's why all of my support for the format is based on beefing it up and making it a lot more than what is currently being proposed.
Right, which is this ITU 2020 proposal, which includes resolution as well as a bunch of other stuff. Just wanted to mention that F-Loop in the chat room is saying it would have been nice to if Rec 2020 had included 1080p profile with the extended bit depth and color space. I wonder why this didn't happen. Any thoughts on that?
I'm not in a position to comment. I certainly
it's what you would like to have happened, right?
Well, it's what I would have liked to have had happen.
Yeah.
But at the time the specification came out, the idea was that we weren't going to try to change our existing system. They were just going to leave that alone, and we were going to create this new system out someplace else, and it was going to hang on its own. But I don't believe that it's going to be worth anything if it hangs on its own. And I believe that it actually has to encompass things that we're doing now and improve what we're doing now. As an example, we can't do 1080p 60 right now. And I would love to be able to do 1080p 60 or 1080p 120. No, 1080p 60 is not part of our current high definition system. You can get 1080p 60 converted from something else. As an example, if you have a 1080i source, there are converters that can convert that to 1080 60, but there is no 1080 60p broadcast.
Broadcast. Yes.
There is no source availability of 1080p 60. So,
and I guess Blu-rays are either 1080p 24 for movies
or 30 24, 24, 25, or 30.
So there are no Blu-rays with 1080p 60 progressive content.
Currently, under the current BD system, there is no provision for 1080p 60.
Wow, I don't think I knew that.
So, but I want it to happen. And why not make it happen as part of ultra high definition? Because that's certainly an improvement over a current high definition system.
Sure.
So I'm trying to figure out how we make this ultra high definition much more interesting to consumers, something that they actually want to go out and buy.
Yeah.
And so that's why I keep talking about applying ultra high definition to 1080 and 720 so that they could be included as well. And of course, that would bring so many more options on board. Because as an example, our source material today, the majority of source material that you watch on television is 10-bit 422 instead of 8-bit 420, which is what's conveyed via the compression system. So all the source material is already a much higher quality than anything that's being delivered. And if we would just include that as part of ultimate high definition so that it would be 10-bit 422 instead of 8-bit 420, most people on their current sets at home would see enough of an improvement to embrace having the ultra high definition in their home. They don't have to go out and buy a new TV set. We just have to have a new system to convey that information. So all that's required is a new version of H.264 as an example, or H.265.
Which we're going to talk about. In fact, we've got quite a bit to talk about in the more specific areas here, but I have to just make a quick comment that I agree with you that if we were to improve these other aspects, as you say, you could see the difference immediately, readily, easily on current TVs and on future TVs. That would be a lot more. That would help a lot more to.
It would be compelling.
It would be compelling. That's the word I'm looking for.
It would be compelling.
Exactly.
And so.
Whereas resolution by itself isn't necessarily, especially on these 50, 55, 65-inch screens that are now being sold as UHD TVs.
You've got it. You've got it. Because if the system isn't a great deal more than resolution, it's going to fall flat on its face.
Yeah. Let me ask you one more question about color gamut before we move on to another of these subjects. Expanding the color gamut is one area where we really could see a big improvement. Does expanding the color gamut increase the amount of data that needs to be conveyed?
It should. If it doesn't, there are a number of people that believe that the increased color space can be conveyed in the same bit depth, the 8 bits that we currently transmit. Well, I'm here to tell you that 8 bits isn't enough for 709 because I happen to have display devices at home, multiple display devices at home that clearly show the shortcomings of 8-bit. So I would get a much better picture if I was delivering 10-bit content as opposed to 8-bit content. And
let's quickly define the 8-bit, 10-bit, what this means. It's the number of bits used to represent the brightness from no light at all to maximum of each of the 3 color channels, red, green, and blue, right?
That's a good starting point in describing it.
Okay.
If I were to go to the geek explanation of bit depth,
go for it.
In the digital world, we sample the analog signal, and every time we sample that signal, we create a digital word, and the number of steps in that digital in that pixel, because that's what we do. We sample, we create a pixel. The number of steps tells us what the dynamic range of that pixel can be, either in color or in luminance. So that we have, theoretically, 256 steps in an 8-bit word to go from absolute 0 to the peak of the white capability. Now, in a 10-bit signal, we actually have 1024, I think that's the number,
that's
1024,
right.
1024 steps to go from black to white. That means there's many more steps. So each time we sample the luminance information and or color information, because when you're sampling red, green, and blue, you're sampling color information.
Right.
The luminance of the individual color. But anyway,
right.
When you have many more samples, that means you can put much more detail into the picture, much more luminance detail, so that you don't get contouring in the face. In an 8-bit word, quite often you'll see steps along minor changes in both amplitude or color in the skin tone. And so it won't look good. It won't look smooth. If you had 10 bits, then the flesh tone would look much more smooth and much more natural.
Mm.
And
12,
by the
12
way,
bits even more so.
Yes, 12 bits even more so. Now, for just the luminance and the color space of 709, you need 10 bits. And the original idea that we could get away with 8 bits was based on a CRT. And it's an analog device, and it rounds things off anyway, and it averages things. Most digital displays are much more precise and much more absolute about what they reproduce. So in digital displays, you see contouring. Now, you can relate this to audio, where 16-bit audio and 24-bit audio sounds a lot nicer, a lot smoother. There aren't the rough spots in the audio amplitude. So you do 16 bits or you do 24 bits. Now, the reason audio needs 16 or 24 is because the amplitude between the noise threshold and the 105 dB or whatever the noise, whatever your threshold of pain is.
Well, it's like 130, but it's...
Yeah, that distance is huge.
Huge.
And in video, the difference between black and white is the difference up to, an average of 30-foot Lamberts or...
we'll call it 30-foot Lamberts or 100 nits.
Yeah, 100 nits. And that's not a very big dynamic range. So in the CRT days, there were a number of people who felt that we could get away with 8 bits in transmitting. But we've got much better displays today. And I want to tell you the difference between 8 bits and 10 bits is huge in picture quality. Mm-hmm. And so we know that in production, we produce everything at 10-bit. We would never produce at 8 bits, or at least I hope not. I hope nobody would actually stoop to producing. It's just like not a lot of people produce at 44.1 anymore. Even though that might be distributed, they at least produce at 48.
We're talking here about audio sample rates.
Yes,
44.1 kilohertz, 48 kilohertz. You record, you digitize an analog audio signal at a higher rate, and then downsample it if you need to for CD or whatever.
Right.
And you get a better quality than if you capture at the final rate you're wanting to end up with to begin with.
Right. So
same thing with bit depth. I understand.
In this discussion of bit depth, in order to go out to the color space, and the color space is a distance away from zero saturation. As much as we talk about luminance bit depth being necessary to get from black to white, we also need a bit depth to get from zero saturation to full saturation. Well, if full saturation is that small triangle of 709, then we don't need quite as many bits to get from there to, say, P3. If we can put up the CIE diagram again that has the multiple triangles, yes, the one on the left. And what you see is if you look at the difference between the ITU 709 and the DCI triangle, you see there's not much of a distance between those two triangles.
Somewhat, but not a big one.
Yeah, not a big distance. But in bit depth, in order to get from 709 to DCI, you've got to go from 10 bits to 12 bits. You can't do a good job of the DCI color space without going to 12 bits. So as much as when you increase an amplitude from black to white, you need more bits. When you increase from no saturation, the center of the diagram, out to saturated colors, you also need an increase in bit depth. So DCI, even though its luminance dynamic range in the theater is 15 or 16 foot Lamberts, which is half what our TV sets are, we still need the 12 bits to get there.
Because of the saturation.
Because of the color saturation. That's right.
Yep.
So what happens is we need a much bigger bit depth than the 8 bits that we're doing now.
And if I'm not mistaken, ITU 2020 specifies up
10
to
or
12 bits.
Yes,
10 or
it's
12.
10 or 12 are the two options in the ITU 2020 specification. I actually included a sheet in my things that actually showed that there's a 10-bit option and there's a 12-bit option, but anybody can download the specification. It's free. It's online. Just type in ITU-RBT.2020 and it'll show you where you can download the document for free.
Right.
There it is.
There it is.
That's the color specification. Let's go to another page, another table that has the bit depth specification. So we'll flip to another page that has the color specification.
There we go. Oh no, that's the
that's 422. That's 444. Okay.
We have 3 of these pages, by the way, and they get mighty geeky. But after all, this is Home Theater Geeks, so
okay. Well, never mind. It's there. 10 bits and 12 bits. There it is. 10-bit encoding, 10-bit coding, and 12-bit coding. Those are the 2 options for 2020. Of course, the irony is we need 12 bits to get out to the DCI color space. And if you remember that diagram, 2020 is way out beyond where DCI is. And
right.
A number of people in the industry have calculated that it's going to take at least 16 bits to get out to the color space. If you look at the difference between ITU to DCI, that's 10 to 12 bits. And then you look at how much further out the 2020 space is, you begin to recognize that you need a lot of bits to get out there. And
smoothly. You can do it with fewer bits, but then it starts looking banded and bad.
Yes, that's absolutely correct. And of course, the whole idea of the ultra high definition system is it's an ultra version of high definition. And you don't get that by introducing a lot of contouring into a picture.
No credit, no kidding. I got a question in the chat room about going back to color gamut or the range of colors, which we've just been talking about. Manny01 asks, as few consumer displays are, there are no consumer displays, I don't think, that can support DCI or 2020. Isn't XV color or XVYCC, XV color is Sony's term for it, the only wide gamut we can hope for in a reasonable amount of displays?
Well, first of all, there's nothing, I got to be careful about that. XVYCC is an undefined color space. And it can be whatever anybody wants it to be as long as they know what it is.
Right.
So when you ask, in theory, almost all the displays that are out there in their unmatrixed position, their raw color position, can support color spaces that are larger than 709. And in theory, you could declare one of those spaces an XVYCC color space. As long as you knew what it was, you could define it. So when Matt asks if, gee, we've already got XVYCC, well, what Company A and Company B are doing for XVYCC in the actual color space are completely different. So I actually believe that we're far better off going to fixed options like 709, P3,
2020,
Adobe RGB,
right.
You know, and I don't think I included it in this one, but no, I didn't. But in some of the committee work we're doing, someone put all the possible triangles of currently defined color spaces on the triangle, and the triangle was just a mess with so many systems that have been defined. There's Adobe RGB, there's sRGB, which is essentially 709, but there were so many options in the computer world in particular for color spaces that you would really not want XVYCC in the fact that it's too complicated. I'm going to go for 4 maximum defined color spaces. And if I were to do that, it would be 2020, it would be Adobe RGB, it would be P3, and it would be 709. And so if I were to build an ultra high definition system, I'd probably include all 4 of those color spaces. Now, to Matt's point, existing sets don't quite go out to P3, in their native mode. Now, original LCD displays actually went out further than P3, but they found that it was more efficient to create light sources that were closer to 709 if 709 was the target. So if Matt happens to have a much older set, chances are the color space in that much older set might have gone out to P3. But of course, that set's useless in the 709 system because the color's wrong.
Right. I've written and said many times that, these new UHD TVs and OLED TVs in particular, if you set them to their native mode, they go way outside of 709, but it's unpredictable. You don't know exactly where it's going to be. It's going to be different from one set to another.
That's as I'm seeing it. And you're 100% right from what I've seen in the marketplace. Now, we don't yet know all the technologies that are going to generate the light in, say, an LCD display, which is the most popular flat panel display technology that's out there.
Unlikely to be for a while.
Yeah, whatever you think of the other technologies right now, we still have to think about LCD in terms of it's the most popular by a large margin.
Yeah.
And so we have to make it work.
Right.
Now, there are 3M has come out with a new backlight technology that they claim can go out to 2020. I have yet to see that, but they claim it can.
Right.
All right. So if we use conventional technology, meaning the white LEDs that are used or the fluorescent bulbs that are used to get light behind LCD now, and of course, it would take laser diode or LED red, green, and blue to get to the 2020 color space. Right now, if those were the only options, we'd have to put 2 color sources in a set in order to get from one place to the other, because neither the color space of the red, green, and blue LED nor the color space of the white LEDs and or the fluorescent lighting can get to both positions. Neither one of them can do both systems.
What about quantum dots?
Well, that's the 3M technology. The quantum dot technology has a potential of covering all the color spaces, but what I haven't seen yet is it doing the 2020 space. Now, the sample of the quantum dot set that we got to play with was doing the NTSC color space, which you may remember the NTSC diagram, and I don't have a drawing of it in providing you with it. You may remember the 1953 NTSC color space was quite a bit bigger.
No,
it's not 601. No, it's not 601. There is no color space defined in 601. There are separate documents that define SMPTE for the U.S. system and EBU for the European system. But 601 does not have a color space assigned to it.
I didn't realize that. Huh. Okay.
No, it doesn't. So there are 2 separate documents defining 2 different color spaces, EBU for the European world and SMPTE for the U.S. world, that get attached to the 601 specification for standard definition.
Gotcha.
So just details.
All details. And we got plenty more to get to. But before we do, I would like to take a moment to thank our sponsor for this program, which is Ting. What is Ting, you ask? Well, it's a no BS mobile phone service. It's a reseller for the nationwide Sprint network, as a matter of fact. But what's different about it is that there are no contracts or early termination fees. This is really cool and really important. In fact, there's a new ETF, early termination fee relief program. If you're going to pay an ETF to come to Ting, they've got your back. They're going to give you credit for up to 25% of your ETF, up to $75 per device. All you have to do is purchase your device through Ting, port your number over, and then submit your final bill with your ETF detailed from your previous carrier. And all you have to do is go to ting.com/ETF for more information about that. There's no bundling or ride-along services. Rates range from XS through XXL service levels for voice minutes, text messaging, megabytes of data, all billed separately. And there are no overage charges or penalties. The other guys charge you if you go over your allotted minutes or texts or data, but if you have a heavier month with Ting, you just pay for what you used. No add-on charges, no mysterious line items on your bill, and in fact, unlimited devices on one plan. You can have as many devices as you want. There's also an powerful online account control panel. I know I'll get that right sooner than later, hopefully. That lets you take control of your account, your usage, and your bill. No problem at all. There's even a no-hold customer support. Good grief. Call 855-TING-FTW anytime between 8 a.m. and 8 p.m. Eastern, and a real person will pick up the phone. How cool is that? How rare is that? And there's great online support as well. So how does it work? First, you purchase your mobile device from Ting, which you'll receive in 2 to 5 business days. Then you activate your device with Ting and have the option to select a new phone number or port an existing one. Ting will break your rates out by minutes, text messages, and megabytes, and your bill that you get at the end of the month for what you've used. You'll see exactly what you used in each of those categories. So visit Ting today at htg.ting.com. Save money and better manage your mobile phone usage with Ting, and check out their savings calculator to see how much you or your company can save. Home Theater Geeks viewers can also save $25 on your first Ting device when you sign up. So visit htg.ting.com and start saving today. And we thank Ting very much for their support of Home Theater Geeks and the entire TWiT network. Okay, so we are getting deep into Ultra HD and the ultimate in Ultra HD. I wanted to, Joe, for you to touch a moment upon color subsampling. You mentioned this earlier. We talked about bit depth.
Yes.
And so you'd love to see 16 bits per color. The 2020 recommendation only goes up to 12. But then there's also this issue of color subsampling. And we talked about this a bit last week with Mike Heiss, and we defined what it is. These are these terms 420, 422, 444. And just to recap briefly, what all they mean is how much of the color information is getting transmitted and how much got removed in order to make transmission easier, to reduce the amount of data that had to get sent across the channel, as it were. And the 420 is the most, well, one of the more highly compressed versions. There's a lot of color information missing from that the TV then has to reconstruct, basically. And that's what we use today, basically. On Blu-ray and DVD, the colors are stored in 420. So there's not very much color information that's actually stored on the disc. And again, the TV or some processor along the way has got to reconstruct all that color. Is that a fair description of what we're talking about here?
That is a really good start in describing what it's all about. And there's a couple of points, a couple of interesting points along the way.
Yeah.
That if you start out with the red, green, and blue channel being equal bandwidth, so when you sample them and convert them to the digital world, you would get what is known as 444. Incidentally, the 4, that nomenclature, and the 2 and the 0, the 4 actually comes from the original digitization of the video signal, where the highest sample rate was 4 times, or about 4 times, the color subcarrier. You may remember the color subcarrier was 3.58 megahertz in the NTSC system. Now that's going back a long way.
That's going back a ways.
Anyway, when we created the digital sampling system, we used a sample rate that was 4 times the 3.58 megahertz. So that's actually where the 4 came from. That we just picked a sampling rate that was 4 times the color subcarrier.
Oh, I didn't realize that. I thought it had to do with the number of pixels, number of luminance pixels versus the number of chrominance pixels.
It's a ratio. It is not the actual number. So when you have a 4:2 ratio, that means that there are half the number of samples in CR and CB as there are in Y.
By the way, Y is the luminance, the black to white range, and CR and CB are the 2 color channels called color difference channels.
That's correct. And so if Y, black and white, is sampled at a rate 4 times the subcarrier, it carries a ratio number of 4. And then what happens is the 2 color difference signals, the R minus Y and B minus Y, are sampled at half the rate. In other words, we take for every 2 samples of black and white information, we take 1 sample of color information.
Yeah. So
therefore, the ratio of color samples is half, or 2.
Right.
So it becomes a 4:2 system, which means that each of the 2 color channels is sampled at half the rate of the black and white information. Now, in 420, it says that the black and white is sampled at 4, and then 1 of the chroma channels is sampled at 2, and the other chroma channel is sampled at 0.
So it's not sampled at all.
That's correct. Absolutely correct. In the next TV line, we sample the luminance again at 4, and then we sample the other channel, the other chroma channel, at 2, and the prior chroma channel that was sampled at 2 is now being sampled at 0.
So in other words, the 2 chroma channels, color difference channels we sometimes call them, one of them is sampled 2 times, half as much as the luminance, on one line, and then the other one is sampled half as much as the luminance on the next line, and ne'er the twain shall meet.
Right. And so what we have is, all right, by doing 4:2:2, we've cut the color resolution in half along the horizontal direction.
Right.
Because along the horizontal direction, the CR and CB channels are sampled at half the rate of the black and white channel. So we've cut the chroma resolution in the horizontal direction by half. Now, if you've ever seen color bars up on screen and you trace along in the horizontal direction, when you get to the green magenta transition, you'll see that there's a black line between them, between those 2 colors. There's a black line. That's because the color resolution can't keep up with the black and white resolution. So there isn't any color. It goes black because we don't have enough resolution in the color to make that transition. Now,
and this is what we're talking about, 420, right?
No, this is 422.
Oh, 422, okay.
This is 422. So when you go along in the horizontal direction, you see, especially it's readily apparent in color bars, you see that there is a loss in color resolution at a transition. Now, we're going to take that one step further, and in subsampling yet again, in one line across, we have one color channel. In the next line across, we have the other color channel, which means we've now cut the vertical resolution of the color in half.
Right.
So if you look at color bars, and you come down a solid color, let's say cyan, and you go into the magenta bar, what you'll see is a gap between the cyan and magenta, because the resolution of the color in the vertical direction is now half. So now you see transitions in the horizontal and you see transitions in the vertical. Now, there's a lot of people that say, okay, you don't see that in a picture. Well, I, of course, differ on that one. And I actually come up with pictures where you can see that transition. Now, the picture that I'm using is the picture of the ICE train, the ICE Intercity Express train.
Right. I think that's the one.
Yeah, there it is. All right. You can see the red stripe down through the middle of the gray. Well,
yeah, the train is basically gray, and it's got a bright red stripe running down the center of the side.
Yeah, it's basically horizontal through the side of the train.
Right.
And what happens is on a good monitor, when you do 420, you look at the vertical transition between the gray and the red stripe, and you see black between them. The gray doesn't meet the red directly. It goes black first because there's not enough resolution to make that transition. So I use the ICE train to make sure that people understand that the lack of color resolution shows up in pictures. And you can actually see the black line as it's showing up in this picture. You can see it goes gray, slightly white, black, and then it finally gets into the red of the ice, of the line around the ICE train.
Of the stripe, yeah. Mm-hmm.
Yes. And so I actually use that. And of course, there's a horizontal transition between the word ice and the beginning of the red stripe. So I can show the lack of color resolution in both the horizontal direction and the vertical direction in that one picture. And you can see that there's a black transition before we red into gray in the horizontal direction as well as the vertical direction. And so it helps me to explain why I need full color resolution on a good display. I need full color resolution. Now, in my 2160p display at home, the set is a 444 set. And of course, all of my source images for my montage of images that I created is all 444. So it means there's equal bandwidth in the red, green, and blue. And so I put those 444 pictures up on the set. And then I put the same pictures up that have been through the 420 process. And even people who don't know any of the technical details look at the difference between the two pictures, and their first comment is, "What happened? What did you just do to the picture?" On a good display, the difference between 420 and 444 will knock you over your head. It's huge.
Yeah. Now, the 2020 spec does allow for 422 and 444, correct?
That is absolutely correct. It does. It allows for 444, 422, and 420. Of course, I was disappointed when I saw the specification even allowing 420 because it's ultra high definition. It can't be ultra high definition if I'm cutting my vertical and horizontal color resolution out of the picture. Not in my opinion.
I agree. Yeah, absolutely.
Not in my opinion.
Yeah.
So wouldn't you like to have that picture quality come back to 1080p and 720p as well as being a part of 2160p? That's why I'm saying ultra high definition has to be far more inclusive than just 2160p.
Now, I got this question on AVS forum in one of the threads of many threads I'm participating in, talking about bit depth versus subsampling, which is what we were just talking about. If you had to choose between the two, if you only could choose one or the other, either less subsampling, full bandwidth in the color channels, or higher bit depth, which would you choose?
All right. I would choose 444 because even 8-bit 444 looks a lot better than 8-bit 420.
Mm.
Oh, incidentally, and we haven't talked about this, that in the process of going from 444 to 420, you actually create artifacts in the picture. You're creating a transition in the picture that doesn't exist.
Right.
And so what happens is when you encode that, you end up wasting bits conveying the error that is introduced by taking information away. It turns out that it's more efficient to encode 10-bit 444 than it is to encode 8-bit 420.
No kidding.
Yes.
Wow.
So it's more because there's less artifacts in the picture.
Right.
And so the picture is easier to encode if there are less artifacts in the picture. And
Of course.
so, and this is something the analog people said, oh, well, before we encode it, we'll take all sorts of information out. And if there's less information, it'll take less to encode it. But what they didn't understand as they were introducing artifacts into the picture. It's just like if you introduce noise into the picture, it's harder to encode. Well, by taking all this information out, you're adding a kind of noise to the picture. And it turns out—
Which makes it harder to encode.
That's right. It turns out that if we went to a 10-bit or a 12-bit 444 system, it could potentially be more efficient to convey that picture than to convey an 8-bit 420 picture.
Speaking of encoding, and we've only got about 5 minutes left, and so I want to make sure we get to this. The current proposal for encoding or compressing the ultra high definition video data is called HEVC, High Efficiency Video Codec, also known as H.265.
Yes.
And I've heard you say that you're not real happy with that particular codec, and I wonder if you would spend a couple minutes telling us why.
That particular codec, as it's defined for the consumer delivery market, is 420. And I believe that it's currently only 8-bit. So it's just carrying on every mistake that we made in the high definition system. The codec that is used to deliver to consumer needs to be at least 12-bit 444. Now, you mentioned before that I was in favor of 16 bits. Actually, I'd be happy if we could get an ultra high definition system that had a mandatory 12-bit 444 system and an optional 16-bit 444 system.
Well, that brings up the next question, which is data rates. We're talking about increasing the bit depth. We're talking about using less aggressive subsampling. We didn't really talk about high frame rates, but that's another issue that will impact the amount of data that needs to be conveyed.
And we didn't even get to high dynamic range either.
And that's another thing.
And we didn't get to picture size either. I'm thinking of all the things that we haven't gotten to yet.
Well, we've only got a few minutes left. So give me your bottom line impression of what you'd like to see in terms of frame rate and dynamic range.
All right. I'd like to see a system that had a mandatory 60 frame capability at 444 12-bit. I would like to see options in the system to go to at least 120 hertz in frame rate and at least 16 bits in bit depth. So, and in color space, if we're going to include 2020, and I think 2020 has got to be an option, not mandatory. I believe that we should go out to P3 as mandatory, and because that's supported easily by 12-bit 444. As far as bit rate, we're going to achieve more efficiency if we start out with a better signal to encode to begin with.
Right.
So I'm not anywhere near as afraid to go to 10-bit or 12-bit or to go to 444 as a lot of people appear to be, because yes, if we truly go to 60 hertz, 12-bit 444, at that point there could be enough motion in the picture to require some very large data rates. And at that point, H.265 or the high efficiency video codec is going to have to be just a little bit more efficient than it is today, or maybe even a lot more efficient. I don't know. But
are there other candidates for codecs that you see that could be used instead of H.265?
Yes, there are. Among the demonstrations that you saw at the SMPTE conference, we were doing everything at a 32-bit floating point system by using a
32-bit 444.
Yes, but it's a floating point system, which means that it can accommodate anything up to 32 bits. And the reality is, I wouldn't mind if it were possible to go to a system like that. The reason for that is at 32 bits, we're never going to get to a source system that's ever going to exceed the ability to encode and decode it. So I actually like the idea of, let's just go to a codec that goes all out, that could encompass more than we could ever imagine in the foreseeable future. And we'd be just done with the encode decode system. We'd build the encoder and decoder once for the next 20 years and we'd be done. I don't know how possible that is, because there's a huge amount of politics involved in H.265. Yeah. And there's a huge number of people that get royalties off H.265. And I don't know if they would be willing to just switch over to a floating point codec, 32-bit floating point that would just give us everything all at once. So I don't know where that's going to go.
Speaking of dynamic range, we were mentioning that earlier. Undermined in the chat room is asking about whether or not we might use something like Dolby's high dynamic range, I think called Dolby Vision.
Certainly Dolby has some interesting proposals for extended dynamic range and or high dynamic range, whichever way you want to talk about it.
Right.
In their system, they talk about specular highlights. I think high dynamic range has got to be a lot more than that. I have two pictures that I had provided you that I shot.
Yes, let's look at that. Let's look at those.
It's a single picture that I shot with my camera. The first is a rather washed out picture. This was taken with my camera, which has a 14-bit dynamic range. Now, the JPEG that comes out of the camera has to pick about an 8-bit dynamic range out of those 14. And this is the 8 bits that it happened to pick. Now, when I fed the 14 bits into my processor, I had my choice of the entire 14 bits that was in it. Let's go to the next picture and I'll show you what section of that 14 bits I chose to expose. So you can see.
And it looks a heck of a lot better. I mean, the first one is all washed out. It was basically probably the top 14-bit, the top 8 bits out of 14.
Right.
And you just moved those 8 bits downward.
Right.
And achieved a much better looking picture.
Wouldn't it be interesting? But all right, first of all, what I'm saying is if you've got a decent camera, you're shooting a dynamic range that's far greater than you can currently display. And so I actually see the value of high dynamic range, not just as specular highlights off a glass or a car or whatever. I actually see it as being able to convey real dynamic range that's in every picture that we shoot, presuming we don't reduce it to a JPEG when we get it out of the camera. Presuming we hang on to the data that's coming off the chip, we have much more dynamic range and we can do much more with the picture. So I use this picture as an example of how much dynamic range is actually being captured and say, gee, wouldn't it be nice if the display could show much more of what we're capturing?
Now that requires the signal to have a greater bit depth of 12, 14, 16, 32 bits, whatever. But it also requires that the display itself have a wider dynamic range in its display, its light output capabilities.
Yes, that's true. Now, in LCD, a lot of computer monitors already have a 10-bit depth. So we know it's expensive, but that's what ultra high definition is all about. It's going to be a little bit more expensive. Sorry about that, but initially it's going to be. So right now, if we did it at 1080p, a lot of manufacturers could put out 10-bit displays immediately. So they could actually build ultra high definition displays out of their computer division and put them out on the market now. And if we sourced at 10-bit, we could suddenly have dramatically better pictures immediately. And as far as I'm concerned, that qualifies as ultra high definition television.
Mm-hmm. Well, that brings up the last question, sort of, is even if we had displays that could do this, we would still need the infrastructure within the content creation community to produce content with the wider color gamut, a standardized wider color gamut, and greater bit depth, and less chroma subsampling, and so on and so forth. Do you see that as something that could happen in any reasonable amount of time?
Well, the production system has been at 10-bit. We actually archived 10-bit 422, but almost everything's done at 10-bit 444, and in many cases it's done at 12-bit if it's anything that's being done for digital cinema. So we actually have a fairly long heritage of creating content that is vastly superior to what we're delivering. And if we created the ultimate ultra high definition television system, we would be able to go back to this material and just deliver it as it's been archived. Even delivering it at 10-bit 422 would get you a much better picture than delivering it at 8-bit 420.
Okay, well, tell us, if you would, what just summarize, what would the ultimate ultra HD what would the ultimate ultra HD parameters include? And finally, answering the question that we started with at the top of the show, what size of TV do you need to really appreciate ultra HD?
Well, part of the reason I want to start from the size of TV, if I may, first.
Okay, sure.
The reason I want to do that is part of the impracticality of 2160p is that you need a 10-foot wide screen to begin to see what's in the signal. But of course,
in terms of resolution.
In terms of resolution. And of course, you actually need a 6-foot wide screen in order to see what's in a 1080p image. And not a lot of people can even go that far.
Right.
So that's the reason I want options in the ultra high definition television system, because I want everybody to get a benefit from ultra high definition. So what I see as a system in ultra high definition is lots of options. So we would have 10-bit options, we'd have 12-bit options, we'd have 422 options, we'd have 444 options, we would have 709 options, we would have grayscale options. We would even, if we were broadcasting black and white, we would tell the set to set itself at 5,500 degrees. I want all of this to come in metadata. First of all, I don't think an ultra high definition system will ever get approved unless everybody's favorite option is in it. But I see this right now, I see this as a good thing, because we can carry metadata that's going to tell the TV set what it has to do to properly reproduce the signal. Now, this provides options for the producer to tell the television set what it's supposed to do in order to get a good picture. And I actually feel if there's a lot of options in this ultra high definition television system, there's going to be less room for manufacturers to screw it up, because they're going to have to do enough different things so that it's going to be easier just to do what you're supposed to do, rather than include all these whatever options, whatever name you want to attach to those options. But I believe that it's actually going to provide the consumer with an opportunity to get to see the picture that the producer wants seen, because with metadata and so many options out there, the TV set is going to have to adjust itself. Now, in the transition, there's going to be a set-top box that is going to take all this metadata and it's going to do its best. As an example, if it's an HDMI connection, it can come out 444. So
but only 8-bit.
Take the metadata. Well, it could come out. The set might only deal with 8-bit, but the set-top box could deliver 10.
Sure.
And so the set-top box is just as we did in the DTV transition. We're going to have another set-top box that's going to interface to everybody's current high-definition set, and it's going to be able to deliver a better signal to that set than anyone has ever delivered before.
Well, that brings up the last question, hopefully, since we're over time here. The TVs that are currently being sold today as UHD, they're going to be obsolete in a couple of years, aren't they?
Certainly, I believe they will be obsolete. Yes, they'll have.
It's a difficult position to put you in. Okay, maybe. Sorry.
Well, they'll need the box just as much as anything else will need the box.
That's true. Okay, you could put a set-top box in front of the TV, or in front of the signal of going to the TV, and that could take care of a lot of things.
Yeah. So, not to worry about the fact that you spent a little bit of extra money for the ultra high definition set today. At least you'll be able to get something more out of the future system when it comes along with a better set-top box, or a set-top box that will merge into your current display.
Right. And unfortunately, we don't have time to talk about HDMI 2.0, which is already probably inadequate for conveying what it is you would like to see conveyed ultimately.
Well, hopefully that's pretty obvious from all the things that I've talked about. Anyway,
very good. Well, listen, we've gone over time. We thank you so much for being here and conveying so much very detailed and geeky information. Thanks again.
Thank you.
So Joe Kane is online at videoessentials.com, and you can find all kinds of information there. By the way, Joe, somebody asked in the chat room if you've written books on this subject. I don't think you have, right?
Well, a book per se, Widescreen Review, mentioning just another publication,
That's
actually compiled articles up to the year 2000, and now all the articles that I've written from 2000 forward are going to be compiled in yet another magazine. So a great deal of what I've written is being compiled into a single space where you can just get everything all at once.
Cool. Well, I'm sure people will want to look for that. But then if you want to see what's going on at the moment, you can go to videoessentials.com. You can find me online, of course, at avsforum.com. You can email me at scott@twit.tv. And you can follow me on Twitter at htgeekscott, also at avsforum. And you can also find previous episodes of Home Theater Geeks right here on twit.tv/htg and on our YouTube channel, youtube.com/twithometheatergeeks. Next week, my guest geek is scheduled to be Derek Smith of Spectracal. They've just come out with a new version of Cowman, which addresses the issue that I've spent a lot of time thinking about, which is how to calibrate your computer display to match your TV when you're working on photos and videos and so on, so that when you play them, once you've finished processing them in your computer, you go and play them on your TV, they will look correct. So I'm looking forward to that very much, and I do hope you will join me for that. Until then, geek out.